Hi everyone, it's Miss Berry. In today's video, we are going over we're starting chapter 5, which is called Discrete Probability Distributions. And we are going over section 5.1, which is called Discrete Random Variables. We talked about discrete and continuous at the beginning of the semester, so hopefully you remember what some of those vocabulary words mean. So remember that discrete variables are going to be those variables that can only take on certain specified values. So think like shoe size or number of siblings or number of people that are enrolled in my class. All right, so those have got to be, those are restricted. That you can't have 7.2 as your shoe size. You can't have 13 and a half people enrolled in my class. All right, so these are going to be variables that can only take on certain specified values is what we're looking at in this chapter and in this section. So you can see that I am using the screen recorder today instead of the recording within the presentation like I normally do. So that means we're using our calculators today. So if you don't have your calculator, go ahead and pause the video and get your calculator out and we'll get started. I'm going to go ahead and share my screen with you guys and try to mute my camera so you don't have to look at me the whole time. Share. There we go. All right. So now hopefully you are seeing my presentation. All right. So we're looking at chapter 5, which is called Discrete Probability Distributions. And then specifically focusing on section 5.1, which is called Discrete Random Variables. So let's begin by talking about what is a random variable. A random variable is defined as a variable whose numeric value is determined by the outcome of some probability experiment. So a random variable is just a variable, something that's a value that can change. And in this case, it's going to be numeric. So it's going to be a number. And that number is determined by some experiment. And then the number is the outcome of that experiment. All right, so an example of a random variable, suppose that we toss 3 coins. So imagine that you have a regular penny. Say we have 3 pennies. We're going to toss each one of those pennies. That's our experiment. Sorry. So tossing the coins, that's the experiment. And we're saying let X be the number of heads that we observe. So that's going to be the random variable. Right, so X is the random variable here. So we had to define the experiment. That a random variable is totally based on an experiment. So we had to define the experiment first, and then we can tell you what the variable is that we're interested in observing. Right, so another word that you heard me use was probability distributions. So let's talk about what a probability distribution is. A probability distribution is just a table or a formula that shows how likely different outcomes are in a given experiment. So it's just a way of finding the probability. So probability distributions might be displayed in tables. That's what we're going to see in this section. And then in the next section, we're going to see how we can use a formula to find those probabilities. So when we're talking about probabilities and probability distributions, there are a couple of properties that we want to remember. First is that all probabilities must be between 0 and 1. We don't want to see any negative probabilities. We don't want to see any probabilities that are greater than 1. All right, so all probabilities must be between 0 and 1, and that's inclusive. So the probability is allowed to be equal to 0, and the probability is allowed to be equal to 1. It just can't be equal to anything outside of that interval. All right, and then our second property is that all of the probabilities in your sample space have to add to 1. All right, so if we're looking at a table, then all the probabilities in that table need to add to 1 for it to be a valid probability distribution. All right, so here's an example of a probability distribution. It says, consider the discrete probability distribution of the number of credit hours that a sample of 20 students from my stats class are currently enrolled in. So here is the probability distribution. You can see we've got X, which is our the values of our random variable. We know that our random variable is the number of credit hours that students are enrolled in. Right, so number of credit hours, that's X. And here's the values of our random variable, X. Right, so students were enrolled in anywhere between 12 credit hours and 18 credit hours. Right, and then in the other side of the table, you can see I've got the probability. So there was a 5% chance that students were taking 12 credit hours. There was a 20% chance that they were taking 13 credit hours, 15% chance that they were taking 14 credit hours, and so on, all the way up to a 20% chance that they were taking 18 credit hours. So if we wanted to verify that this was a valid probability distribution, you could add up these probabilities. So you would just do 0.05 plus 0.20 plus 0.15 all the way down to the bottom. Make sure that those add to 1. That would be one way of verifying that this was a valid probability distribution. I'm just adding them up on my own over here just to make sure. I haven't double checked. Oh, there actually is a problem. They don't add to 1. They add to 0.95. For some reason, I thought I remembered that. All right, so let's just change one of these. Let's just make this one right here be 0.15. I think I'll go ahead and fix this on y'all's notes before I put this video out, so that way you'll have the correct number in there. Okay. So we are asked to do 3 things here. We have 2 more after this, but for right now, we're just focusing on these 3 things. We're asked to find what is called the expected value, the variance, and then the standard deviation. Right. So when we are finding the expected value of a probability distribution, there are a couple of ways you can do it. You can do it by hand. It's really not that hard to do it by hand. But I'll also show you how to do it in the calculator as well. All right. So expected value is just another word for the mean. All right. So the expected value is another word for the mean. All right, so when you see the phrase expected value, just know that that's referring to the mean, just like we've calculated in the past. All right, and then we're also asked to find the variance and the standard deviation. All right, so let's get our calculator. All right, so we're going to use the same buttons that we used back in chapter 3. We're going to hit the stat button, which is right here, sort of diagonal down to the left from that little arrow button. All right, so right here, hit the stat button. Then you're going to go to edit, which is option number 1. You're going to clear out anything that you have in your list. Remember how we do that? We go to the very top and we hit clear enter. It's going to clear out the entire list. You got to go all the way to the top, make sure the name of the list is highlighted, and then hit clear enter. All right, so I'm just going to type my table in here. So I'm typing all of the values that we saw here in this table. So all my X values, 12, 13, 14, 15, all the way to 18. I'm going to type that into L1. So let's do that. 12, 13, 14, 15, 16, oops, 17, 18. Okay. Then I'm going to go over here to L2. Then I'm going to type in my probabilities. So the 0.05, 0.20, 0.15, 0.15, 0.15, 0.1, and 0.2. All right, so let me get it on. Shoot, sorry. Trying to see if I can see both of them at one time. Okay. There we go. Now I can see both of them. Okay, great. 0.05. Oh my gosh. As usual, I'm having technical difficulties. There we go. 0.20, 0.15, 0.15. Oh, start over. I need to pay more attention. Okay. Okay. Got it. All right. So now that you have gotten those typed in, you are going to do the exact same thing when we found the mean in the past. You go back to stat and you go over to calc, and then you're going to select the first option, 1 bar stats. Now, in the past, we left frequency list blank. This time you're going to tell it, okay, I want you to look at L2 as well. So to get L2 to pop up there, you're going to hit the second button and then the 2 button. So second button and then the 2 button. You can see that's the L2 button. All right, so second and then 2 pops up L2. Then we go down to calculate, hit enter, and there's all of our one variable statistics. So we've got our mean, we've got our standard deviation right there, and we've got our quartiles, our maximum, our minimum. All right, so let's go back to our screen. All right, our expected value was 15.25. All right, so 15.25. Expected value of x is 15.25. Now, what does that mean? This is credit hours, so we're expecting that on average, students are taking about 15 credit hours. So if we were to round that to the nearest whole number to make it make sense for this variable, students are taking about 15 credit hours. All right, next we're asked to find the variance. We know that the variance is just our standard deviation squared. All right, so let's grab our standard deviation. For our standard deviation, we'll just do 2 decimal places, so 1.92. At 1.92. And then we got to square that. All right, grab our calculator again. 1.92. Squared button is right here, diagonal up from the 7. All right, so we'll say 3.69, rounding that up because that 6 tells us to bump that 8 up to 9. All right, so 3.69. Okay, let me circle that one as well. Okay, and then our standard deviation, we already found that one. Our standard, whoops. We know that the symbol for our standard deviation is S if we're talking about the sample, which we are here. It uses sigma for the symbol on our output, as you just saw. I don't want you to worry too much about that. That's sort of beyond the scope of this class. But just know that it will leave S blank and it will report the standard deviation in that sigma line. All right, so we've got our statistics here, our expected value or slash mean. We've got our variance and then our standard deviation. All right, so if you're given a table, you could also be asked about the probabilities, asked to find probabilities from within that table. All right, just fixing that. All right, so it says find the value of the probability that x is less than or equal to 16. All right, so probability that x is less than or equal to 16. That's this part of the table. So 16, 15, 14, 13, 12. So we're just going to add up all those probabilities. All right, so you can see I had this written from before. So that'd be 0.15. This one should be also, make this one 1.15 as well, which makes that 0.70. All right, so you're just adding up all those probabilities from the table. All right, and then probability that x is greater than 13. All right, if x is greater than 13, that's all of these people. Once again, we have to change that to 0.15. And then again, I've got this wrong, so I need to fix that. All right, so 0.15, that's 30. Another 0.15 is 45, then 55, then 75. All right, so let's change that to 0.75. So this means about 75% of students are taking greater than 13 credit hours. About 75% of students are taking greater than 13 credit hours or more than 13 credit hours. All right, so next we have a little bit of a more complicated problem. On this one, they're not going to give you a table. You have to make the table yourself. It says, construct the discrete probability distribution for the random variable described, and we're supposed to express our probabilities as simplified fractions. All right, so it says the number of heads in 5 tosses of a coin. So why is this discrete? Well, we can only observe a whole number value, right, for our number of heads. So we could observe 5 heads. If we toss the coin 5 times, we could see 5 heads. We could see 4 heads, 3 heads, 2 heads, 1 head. And then we could also see 0 heads. So we could get all tails. Right, so those are our different outcomes that we might observe in this experiment. Right, so let's think about what are the total number of outcomes that are in our sample space. That's going to be important, right? Because probabilities are calculated as success over total. So we need to know what is the total number of outcomes that we're working with here. All right, so we're going to use that fundamental principle of counting. So again, I like to think of these as like boxes. Each box is like one like selection in the experiment. So in this case, this is the 5 tosses of the coin. Each time we toss the coin, you could observe 2 possible outcomes, either heads or tails. All right, so then we just multiply those together to get the total number of outcomes in the sample space. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 outcomes in that sample space. All right, so now we've got all of our possible outcomes. That'll help us make, if you remember from our previous slide, we did a vertical table that time. We had x and then the probability that x equals little x. So we need to write our outcomes here. So that's going to be 0, 1, 2, 3, 4, and 5. And then we'll calculate our probabilities for the right-hand side. All right, so I did the table horizontal here. It really doesn't matter. I just wanted to show you different options. So you can do vertical tables, you could do horizontal tables. They're all the same. All right, so we've got our, let me switch to my laser, sorry. All right, so we've got our outcomes here. You could observe 0 heads, 1 head, 2 heads, 3 heads, 4 heads, or 5 heads. And now we need to calculate our probabilities. We know that the total number of outcomes is 32, and we can use our the stuff that we learned about combinations and permutations to figure out like how many, to count up the total number of outcomes that are going to have 0 heads, or the total number of outcomes that are going to have 1 heads. Right, and so let's think about if the order matters here. Does it matter if you observe the head in the first toss or in the second toss? Does the order matter in which you observe the heads? Absolutely not. Right, so it doesn't matter if you, when you're tossing the coin, it doesn't matter if you get heads, tails, 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 or if you get tails, heads, tails, tails, tails. Right, so that's still 1 head. This is still 1 head. All right, so the order doesn't matter here. So when the order doesn't matter, we can use combinations. When the order does matter, we use permutations. So since the order doesn't matter here, we're using combinations. And we're going to be finding the probabilities. Remember, probability is success over total. We know that the total was 32. Right, so right now we're just looking for like how many of those outcomes have 0 heads? How many of those outcomes have 1 heads? All right, so to figure out how many of those options have 0 heads, that'll be 5 choose 0. 5 choose 0. Let me pull up our calculator. 5 choose 0. So 5, go to the math button, over to probability, and then there's option number 3. 5 choose 0. There's only one way to get no heads. Right, so there's only one way to get no heads. So success is going to be 1, so that's 1 over 32. Well, sorry, I don't know why that zoomed in. There we go. Now, we need to figure out how many options out of the 32 outcomes, how many of those have 1 head. All right, so that's going to be 5 choose 1. 5 tosses 1 head. All right, so let's pull up our calculator and find 5 choose 1. 5, hit the math button, go over to probability, go down to the combinations. 5 choose 1 is 5. All right, so there are 5 ways that we could have 1 head, which I think that makes sense based on like what I started drawing up here. You could have the head in the first position, the second position, the third position, the fourth position, or the fifth position. So those are all of your options for how you could get 1 head. All right, so 5 out of 32. All right, now we got to figure out how many of those, out of those 32 outcomes, how many of those had 2 heads. So that's going to be 5 choose 2. All right, so let's do 5 choose 2. 5, math button, and choose R. 5 choose 2 is 10. All right, so let's fill in our table. So it's going to be 10 over 32. Now, they did say to write simplified fractions, so these both are divisible by 2. So we got to reduce this. So 10 divided by 2 would be 5. 32 divided by 2 would be 16. So that reduces to 5 over 16. All right, and then now we got to just keep repeating the process for 3 heads, 4 heads, and 5 heads. All right, so for figuring out of those 32 outcomes, how many of them are going to have 3 heads, we do 5 choose 3. All right, so let's go to our calculator. 5 choose 3 is also 10. All right, so again, 10 out of 32, which once again can be reduced to 5 over 16. All right, then for 4 heads, how many ways are there to observe 4 heads? It's going to be something out of 32. Let's figure out what the something is by doing 5 choose 4. All right, so 5 choose 4 is 5. All right, so 5 ways to observe 4 heads. All right, so 5 out of 32. 5 ways to get a success there. And then lastly, how many ways are there to observe 5 heads? All right, so we know it's something out of 32. Let's figure out what the something is by doing 5 choose 5. All right, so you can already see the answer there, but let's go ahead and do it. 5 choose 5 would be 1. All right, so 1 out of 32. Notice the symmetry here. That's kind of nice. Like whenever you get half the table filled in, the other half is symmetric. So that's kind of cool. All right, so that's our probability distribution. You could verify that this is a valid probability distribution just by making sure that all those probabilities add to 1. I'm going to do that real quick. Out of 32 plus 5 out of 32 plus 5 out of 16 plus 5 out of 16 plus 5 out of 32 plus 1 out of 32. Perfect. They all add to 1. Okay. And then our last problem, once again, another one where we have to construct our own probability distribution. It says, suppose that you and a friend are playing cards and you decide to make a wager. The bet is that you're going to draw 2 cards from a standard deck of playing cards without replacement. Right. So once you draw a card, that card's going to get taken out of the pile and you can't draw it again. Right. So you're drawing 2 cards without replacement from a standard deck. Right. We know that a standard deck has 13 cards per suit, 4 suits. So that's 52 cards in total. So a standard deck has 52 cards in total. It says if both cards are diamonds, your friend's going to pay you $20. Otherwise, you have to pay your friend $5. Right. So if you get 2 diamonds, you're the winner. You get $20. Anything else, you're the loser and you have to pay your friend $5. All right, so we're supposed to be finding the expected value of this bet. Sorry, that's like a little bit covered up there. The expected value, which is the mean of your bet. Oh, and that just reminds me, I forgot to show y'all how to calculate the expected value by hand. So I'll do that here. All right, so find the expected value, round your answer to 2 decimal places, express losses as negative values. So 2 decimal places makes sense here because it's talking about money. All right, so money, we always do 2 decimal places. All right, so let's think about what are the outcomes here. All right, so there's our, just making our little table, X and then probability of X. All right, there's 2 outcomes in this game. You could either win or you could lose. Sorry, I'm getting emails. All right, so in this game, you can win or you can lose. Only 2 outcomes. If you win, you get $20. All right, so if you win, you get $20. If you lose, you have to give your friend $5. So that's -5. So now we just need to find the probabilities. So let's start by finding the probability that we win. And then we'll use the fact that we know that these 2 numbers need to add to 1 to find the other probability. All right, so let's find the probability of winning. All right, so if you win, that means you got a diamond and a diamond. And remember, this is without replacement, so we're going to change the total. All right, so remember when we're doing when we're drawing cards or when we're making choices without replacement, then the total is going to change. All right, so a diamond and a diamond. So we're going to use our multiplication rule for the and rule, but we are going to have to change the total since we're doing this without replacement. All right, so there are, how many diamonds are in the deck? How many diamonds are in a deck? 13, right? Right. I'm just seeing that I used some of the wrong numbers, so I'm just deleting all this. Behind the scenes. Okay, there we go. All right, there we go. Probability of winning. You get a diamond and a diamond. There are 13 diamonds in a deck, right? There's, if you don't know anything about playing cards, which I think we did talk about that a little bit, there are diamonds, hearts, clubs, and spades. There are 13 of each of these suits, is what those are called, the suits. All right, so there are 13 diamonds in a deck. So we have a 13 out of 52 chance of drawing a diamond the first time. All right, but then if we draw a diamond, we take that diamond, that card gets taken out. There's only 51 cards left. And if we drew a diamond the first time, there's no longer 13 in there. There's now 12. All right, so let's calculate that probability. Let's get our calculator. 13 over 52 times 12 over 51. 13 out of 52 times 12 over 51. All right, let's see if we can make that into a fraction. Nice, 1 out of 17. Okay, let's get our PowerPoint back up. Okay. 1 out of 17. Was that right? Let me just verify. Yep, 1 out of 17. Perfect. All right, so let's revisit our probability distribution. We said there's a 1 out of 17 chance that we win. All right. If these have to add to 1, if you win 1 out of every 17 times, then you lose 16 out of 17 times. Does that make sense? So if you win 1 out of every 17 times, let me switch to my laser. If you win 1 out of 17 times, then you lose every other time. So 16 out of 17 times you're losing. All right, so let's calculate the expected value. So again, you could type this into your calculator. You could do, let me show you. You could go to the stat button. Let me go back and clear out everything. I like to start with this clear screen when I remember. All right, so we go to edit, clear out everything that's in there. Then you put in your outcomes there, so 20 and -5. Then over here you put the probabilities. That's 1 out of 17. And then 16 out of 7. Whoops. Gosh, stop. Okay. 17. There we go. All right, then you could go to stat, go to calc, and do your one variable stats. We've already got frequency list as L2, so we don't need to do that again. And then you hit calculate, and there's our expected value. So 2 decimal places would be -3.53. -3.53. Let me get my pen. Expected value would be -3.53. All right, so let me show you how you could do that by hand. All you have to do is you take your outcome, multiply it by the probability, and then plus outcome times probability. And then you would repeat that for every outcome you have. This one's the easy one because there's only 2 outcomes. So you do outcome times probability, 1 out of 17, plus outcome, -5, times the probability, 16 out of 17. And there's the same number, -3.53. All right, and then on part B, let's look at part B. All right, so part B says, suppose that you made this bet every day for an entire year. How much would you expect to win or lose? So if you were losing, what did we say, $3.53? $3.53. So every day we lose $3.53 for 365 days. Multiply that in your calculator, -3.53 times 365. We would expect to lose $1,288.45 over the course of the whole year. All right, and then I said that was the last problem, but I told a story. I'm sorry. Here we're looking at which plan has the higher payout. So you're just finding the expected value. So find expected value for both. Now that we know that easy formula to find the expected value, let's just do that. So we're going to multiply the payout or the outcome times the probability. Then you're going to add that to outcome times probability, and then you're going to do the same over here. All right, so negative 10,000 times 0.63 plus 0 times 0.05 plus 55,000 times 0.32. All right, that plan has an expected payout of about $11,300. So this is like we would imagine like an insurance plan. All right, and then now I'm going to do the other table, negative 45,000. Whoops, let me clear that out. Negative 45,000 times 0.16 plus 5,000 times 0.27 plus 70,000 times 0.57. All right, much higher payout on that one, $34,050. All right, so that first one was 11,300. This one's 34,050. So Plan B has much higher payout. All right, that is the end of this section. If you have any questions, please let me know. Otherwise, I'll see you guys in the next video. I hope you have a good day.